maybe you thought you missed something, you can always go look it up. So we're now going to finish up 2.5. And we're going to talk about consecutive integers, what they are, and how they relate to each other. Consecutive integers are just simply back-to-back numbers. So an example of consecutive integers might be pages in a book. And 1 is there as well. Those are all consecutive integers. Okay, 1, 2, 3, 4, you could even go up to something like 250, 251. Now, the important thing is look at the gap. The gap between each of these numbers is the gap of what? 1. Okay, so that's going to be very important. When we talk about consecutive integers, they have a gap of 1. So what we do is we start off with our first number, all right, and we call that first number x. Now the second number, that's going to be, let's say I'm at 3. Okay, if I want the next number, which would be 4, what do I have to add to 3 to make it 4? X plus 1. Okay, what about my third number? Okay, if I'm at 4, how do I get to 5? Add another one, right? So that's going to be x plus 2. And if I need the fourth number, let's say, okay, that would be if I'm at 5, how do I get to 6? I still add what? Another one. So that would be x plus what? 3. See, I'm adding 1 every time. So the number of numbers that I have, I always call the first one x. Second one is x plus 1. Third one is x plus 2. Fourth one is x plus 3. Fifth one would be x plus 4, and so on. So you're adding 1 every time because that gap between the integers is 1. Now, what about even or odd consecutive integers? Well, let's talk about even integers. And these are also consecutive. So these are even integers that are consecutive. So that would be things like 2, 4, 6, 8, 10, 12, and so on. What about the odd ones? So what are the odd ones going to look like? Okay, yep. The odd integers would be things like 1, 3, 5, 7, 9, 11, 13, and so on, right? Now, these, what's the gap between these? Both of these have a gap of 2. So what we're going to always do is start off with our first number. And if I was working with even or odd, I would start off with my first number, again being x. And then what am I going to do for the second number? I'm not going to add 1. I'm going to add what? 2. And my third number, I add 2 again. So that would be 4, right? And the fourth number, if I wanted that one, it would be x plus what? 6. Do you see the pattern here? So what do? I always start off with the first number being x. If they're just plain consecutive integers, you add 1 every time. If they're even or if they are odd, what do you add? 2. Now, when we read these questions, the first thing we look at is how many of them that we need and what type they are, whether they are just consecutive integers or whether they are even or odd. And that's going to help us build these numbers, and then we come up with our equations from there. So let's start off with a really, really easy one. Question 54 on page 145. These, I think, are actually a little bit easier. So question 54. Two apartments have numbers that are consecutive integers. The sum of the numbers is 59. What are the two apartment numbers? Well, what do we know? Are these even or odd? No, they are just consecutive integers. How many apartments do I need? 2. Okay, so when I look at this one, what do I know? I know my first number is always x. Now, these are just consecutive integers, so that's going to be x plus what? 1, right? Now, what's happening with these? Well, we're looking at question 54, two consecutive integers, and they sum to give you what? 59. So that means the first number plus the second number is going to be 59, right? We've got our two numbers laid out. Now what do? Now we fill them in with our variables. So integer number 1, that's going to be x. Integer number 2, that's x plus 1. And what is that total equaling? 59. Add them together. Always do that first, so those can go. That gives you 2x plus 1 equals your 59. And now we should know what to do. So I want to get the 2x by itself. That 1 is positive, so I subtract it off. And that leaves you with 2x now equals what? 58. You're going to now divide by 2. And x equals now what? When I divide, 58 divided by 2, that's a 29. Now, I need to get both of my numbers, because it says find both the apartment numbers. So what are the apartment numbers? 29, and the next number is what? 30. So there is my answer, 29 and 30. Make sure you get both of them. Now let's look at even and odd. 58. This one's going to be an odd one. And what's the gap for the even or the odd numbers? 2. So we have to make sure we remember that fact, gap of 2 every time. So we're looking here at 58. Two consecutive odd integers such that twice the greater number is 17 more than the lesser. So first off, find two consecutive odd integers. So that means I need two numbers and they are odd. So we'll start with that. And so the first number for odd integers is x. I need two numbers, so my second one is x plus 2. Is everyone okay with how I did that? So the first thing I did was I read that little bit of information. And we got that. Okay. Now, what does it look like? It says such that twice the greater okay. Let's see here. Is means equals 17 more than the lesser. So is means equals 17 plus the lesser. Now, when we talk about the lesser and the greater, I put it up in words, but those are going to match back to the numbers. So when we look at this, which one's the lesser and which one's the greater? Okay, the greater is going to be the bigger number. So in this case, the greater number is going to be the second number, right? Because it's plus 2. And what about the lesser number? That's the first one. Now we've got our equation, right? And we can fill it in. But you see how I did that? I used greater and lesser, and then I thought, okay, which one's bigger? This one has a plus 2, so it's the larger number. This one would be just x, so it's a smaller number. Now we can fill it in. So that is now 2 times x plus 2 equals 17 plus the x there. We should be fairly confident now to solve equations. And so we distribute that 2 through. And that is now 2x plus 4 equals 17 plus x now. What do we need to now do? Well, now we need to move that x over. 2x minus x, that leaves you with a single x, plus 4 equals 17. Move that 4 over with subtraction. And now we've got our x, which in this case, x now equals what? 17 minus 4, that's a 13, isn't it? What are my two numbers going to now be? 13, and the next number would be what? 15. We want them both, so there they are. So sometimes you have to be careful with the greater and the lesser. If it's written like that, remember, greater is going to be the larger number. Lesser is going to be the smaller one. So the first one is the lesser. The greater one is going to be the second number. That way you don't get them mixed up. Build your equation and solve it. Question 62. Question 62, we have more numbers to work with. Question 62. If the sum of 3 consecutive odd integers is 69, what is the third of the 3 odd integers? So, first off, what do we know? We know we need some integers, and what are they? They are odd, right? Okay, so what's my gap then? Gap is 2. How many of them do we need? We need 3 of them. So we know they are odd. We know we need 3 of them. So the first one is x. Second one is x plus 2. Third one now is x plus 4, right? Because we're adding 2 every time. And what do we know from our problem here? We know that they sum to give me what? 69. So that tells me that the first number plus the second number plus the third number is now that 69. So now we can fill it in. So first number is x. Second number is x plus 2. Third number is x plus 4. And what does that now give you? That gives you 69. Now we can solve it. So on the left-hand side, combine like terms. That gives you 3x. And number-wise, 2 and 4 makes it 6. How do we finish it? We move that 6 over, and that gives you 3x equals now 63. And what do we now need to do? Divide by 3. And that leaves you now with x equaling what? 63 divided by 3, 21. Okay, now let's go ahead and get our numbers. So we've got 21, add 2, we get 23. Add 2 more, we get what? 25. Now, what does it specifically want? It says, what is the third of the 3 odd integers? So the third number here would be the 25. And you can write them all down. If you wrote all 3 of them down, that would be fine. As long as you write somewhere down the 25. You can put them all down or just write down the 25. As long as you got the 25 somewhere, if this was a question on your homework, as long as you got that 25 somewhere, I would give you full credit for it. One more of these, and then we'll move on to the next section. Okay, so one more. Let's look at 64. The first and the third of 3 consecutive even integers are added together. The result is 22 less than 3 times the second integer. Find the integers. So the first thing I need to determine is how many integers I need and what type they are. So when I read it, I saw that we needed 3 integers and they are even. And if we have even integers, that means my gap is 2. So let's go ahead and write that out. So we add 2 every time. So there they are, all 3 of them. Now, if the first and the third of 3 consecutive even integers are added together. So first and the third. So let's take care of that. That's the first number plus the third number. Those are going together. Are added together. The result is, that means equals, 22 less than 3 times the second integer. So 22 less. That means my 22 is going on the end, and it's being subtracted off. And what am I taking that 22 away from? 3 times the second integer. So that would be 3 times the number 2. Is everyone okay with why I put the 22 at the end? Because it's taking it away from it, right? We have to watch the wording. If we read it, it says, result is 22 less. So that 22 had better be on the end with a negative because it's taking it away. And we're taking it away from 3 times the second integer. Now it's simply fill it in. So the first number is x. Then we need the third number, which is x plus 4. And that's going to equal 3 times the second number, which is x plus 2. And then we've got a minus 22. Okay, 3 has to be distributed through. I'm going to work from left to right. So let's go ahead and put these x's together. And that's going to make that on the left-hand side, 2x plus 4. The right-hand side, that's going to be 3x plus 6 minus 22. Okay, the 6 and the minus 22 can go together. 6 minus 22, 22 is a larger number. It's negative, so that gives you a negative 16 there. And we need to finish it. So we should know kind of what to do. I like to do the same pattern every time until we get good at solving these. You can deviate from the pattern, but the way I always do it is the variables go to the left. And now we have 2x minus 3x. That leaves you with a minus x plus 4. Those cancel. And that equals now a negative 16, right? Watch your signs there. Be very, very careful with things. Now, what do? Yep, subtract our 4 over. And we get a negative x equals now a negative 20. And can we have a negative x? Nope. So what do? Divide by a negative 1. That switches your signs. So now we have x equaling what? 20. Okay, we want all 3 of the numbers. So what would they be? 20, add 2, 22, add 2, 24. Those are my 3 consecutive even integers there. Now that should have completely finished up 2.5. Now we're going to move on, and we're going to move on to 2.6. And I think you'll find 2.6 to be a little bit easier in some cases. to 6, there are different types of equations and problems that we're going to be looking at. We're going to be looking at geometric figures. We're going to be talking about angles again as well. Whenever we need a formula for a geometric figure, they're going to be in the back cover of our textbook. So if we need a formula, we look it up. You just think about what you've got, look up the formula, and then you plug the values in. These I think you'll find to be easier, because a lot of these are just plugging in values. So we're going to be plugging numbers in. We find the correct figure, we plug the values in, we get our answer. Okay, so we're going to now be looking at 2.6. And let's look now at, how about question 42? We're going to start with question 42, and this is on page 153. We read these just like we did all of the others. We identify what we have. We find the correct formula, we plug it in, and we get our answer. So question 42. Okay. The width of a rectangle is 3 feet less than the length. The perimeter is 62 feet. Find the length and the width of the rectangle. Now, what do we know first? We know it's a rectangle. So let's try and draw our picture up here. And then we'll go to the back cover and we'll find our formula. So we know we have a rectangle. And this rectangle has a length and a width. Okay, so how are we going to label it? Okay, it says the length of a rectangle, the width of the rectangle is 3 feet less than the length. Now, we don't worry about the feet until the very end. That's going to be our units of measure, so we don't even worry about that until the very end. So the width of a rectangle is 3 feet less than the length. So the length we don't know, so that's going to be our unknown. Now, what about the width? It says it is what? 3 feet less, right? So the width would be x what? Minus 3. You can write it out in words, but I think we've done enough of those now that you can probably bridge that gap. What else do we have? We have a perimeter is 62. Now we find the formula. You can either remember that the perimeter is simply adding up all the sides, or you can go to the back cover of your textbook and you can look up your formula. Okay, so here's our formula. Either add up all 4 sides or use your formula. This is a rectangle. So the formula for the perimeter is P equals 2L plus 2W. Here's our formula. Okay, let's go ahead now and fill in our pieces. We're going to make it work for us. So, what do we know? We know our perimeter is going to be what? 62. So I'm going to put this over here. What do we know about the length? We know we have to have 2 of them, right? And length is going to be what? Actually, you can put parentheses around it or not. Doesn't matter. And then what about the width? That is 2. And what's the width? X minus 3. There we are. Now we have it. Is everyone okay with what I did there? And you don't have to put the parentheses around the x. I do it because sometimes the textbook does it too. So sometimes I try to change it. So you see how it's done different ways. What do we do with that 2 in front of the x minus 3? We distribute it through, and we stop at the minus 3. So we don't really need the parentheses here, so that's going to be a 2x. We distribute through, that's 2x. 2 times a negative 3, that's a negative 6. And that equals our 62. Okay, we're going to add these together, and that's 4x minus 6 equals our 62. We'll finish this by adding 6 to each side. And 62 plus 6, well, what does that now give you? 68. And 68 divided by 4 should come out evenly. I know it does. Yep, and that comes out, and that gives you x equals 17. Okay, so let's go ahead now and get our dimensions of our figure. Now, what are these measured in? Everything is in feet, so that's going to be the unit that we use. We want to find the length and we want to find the width. So the length, 17 feet. We put our units on at the very, very end. So the length is 17. What about the width? Well, that would be 17 minus 3, which is then what? 14 feet. So we've got 17 by 14. And that's going to be your rectangle. So we just looked it up. We found the correct figure from the back cover and plugged our values in. Let's look now at, how about question 58? Or not 58, 56, sorry. We'll do 56, then we'll do 58. Always read the directions at the very top. We'll do that first. Now the directions here, it says, use a formula to write the equation for each application and then solve. It says use 3.14 as an approximation for pi. So we don't want to use our pi key in this case. It says use 3.14. So we're going to use 3.14 for the Greek letter pi. So let's look at 56. So don't use the pi key. It says specifically not to use the pi key. If it doesn't, you can use the pi key in your calculator. But for this one, it specifically says use 3.14. That's what it says to use. That's what we're going to be using. A drum is played at the Royal Festival Hall in London, and it had a radius of 6.5 feet. What is the area of the circular face of the drum? What is the circumference of the drum? So if I think of a drum and I look at the top of a drum, what do I have? I have a circle, right? So that's what we're going to be working with. We're going to be working with the circle. And we know that radius, it tells us, is 6.5. And that's your radius. Okay, so that's our radius. We know our radius is 6.5. Don't worry about the units until the very end. Now, what are we trying to find here? We want to find the area and the circumference. We have to find both. So we're going to look up our formulas and we're going to find them. Okay, so let's go to the back cover of our textbook and let's find our formulas that we're going to be using. This is a circle. Okay, there's our area, pi r squared. And now we have two different formulas for the circumference. Which one do we have? Do we have the diameter or do we have the radius? Radius, so we're going to use the 2 pi r for the circumference. So let's write down our formulas here. So we know the area is pi r squared, and the circumference is 2 pi r. Now we can simply plug our values in, and we can work out this question. So let's find our area. All right, so area is going to be pi, which is 3.14, times 6.5, and we have to square it. What does that come out to give you? Okay, well, let's make sure we do it correctly. So 6.5, I'm going to do my squaring first. I use a calculator. So 6.5, and I hit my square key. Okay, there's your 42.25. And then we're going to multiply that by 3.14. And that gives me now 132.665. And that's not in feet. This is an area. Now, area, we have to square it. So your area is in square feet. Think about the area. If you square something, your answer better be in square feet or square units. So that's why the area was in square feet. Now the circumference we just multiply. And what would the circumference be? It would be 2 times 3.14 times 6.5. And now that comes out to be what? Okay. That comes out to now be 40.82. And did we square anything in this circumference? No. So my units of measure are going to be in what? Feet. Area is always square units. Otherwise, it's just the base unit, which in this case is feet. So that's how we work those out. Okay, we go to the back cover of our textbook, we find the correct formula, and we work it out from there. I think we'll do 59 instead of 58. Okay, 58 works with a trapezoid, but I think 59 is something that is a better question for us. So we're talking about how the mail service calculates package pricing when they mail something out. So that the U.S. Postal Service requires that any box sent out by priority mail have a length plus the girth. Now the girth is just your distance around, totaling no more than 108 inches. The maximum volume that meets this condition is contained by a box with a square end, 18 inches on each side. What is the length of this box? What is the maximum volume? So, when we look at this, we need to make sure we understand what we've got. We've got a package. So let's draw up our package. It's a three-dimensional object, right? So it's called a rectangular solid. So let's go ahead and draw up our, in this case, our rectangular solid. And I'll try to draw it as best that I can. But it's definitely 3 dimensions. So here's our container. Now, what we're looking at is, we'll come back to that 108 in a minute. We need to first figure out what our box really looks like. That's going to be our step 1, to determine what the box should look like. Okay, it's a box with a square end, 18 inches on each side. Okay, so the box is a square end, 18 inches on each side. So this is going to be square here. So that's 18 by 18, right? Is everyone okay with that? We got to first figure out the box. Then we'll think about what we've got. We'll find the formulas. We'll use the formulas. So it's a square end on this box. Now, do we know the length of this box? No. So the length of the box is unknown, so I'm going to call that x. Why is it 18 by 18? It says the maximum volume that meets this condition is contained by a box with a square end. Okay, that's that. 18 inches on each side. So that's what we've got. Now, what we do not know is we do not know the length. Now let's try to come up with our equation. So the U.S. Postal Service requires that any box sent by priority mail have a length plus the girth. And girth is the distance around. Now let's go ahead and find the girth. Okay, so the girth is this distance around here. You can look at the picture too. Okay, the girth is this distance here. The distance all the way around. So what would that be if I go all the way around here? 18 plus 18 plus 18 plus 18. Okay, and that's going to be my girth. Distance all the way around. If I add that up, that's 4 of those. So 18 times 4 is what? 72. So I'm breaking it up into pieces. First thing it says is the girth. Well, we found the girth, right? Girth was 72. And it says it can have a length plus the girth is 108. Okay, well, we know what the length is, right? Length was unknown, so that was our variable, x. Now, we calculated our girth a moment ago, and our girth was 72, and that equals our 108. And now we can finish it, so we can move that 72 over. And now we've got our x, which is 108 minus our 72, and that is 36. Now, that is not what it wants. We're getting close, though, right? So we now have our figure completely diagrammed out. And that's our 36 for the length. Now, what do we want? Okay, it says we want the volume of this. So always make sure you find out what they want. Now we have it all completely diagrammed out. Okay, everything has been dimensioned. We're going to go to the back cover of our textbook. And this is what's called a rectangular solid. And what do we do for our volume? Length times width times height. So all 3 measurements get multiplied together. So we need to find this volume. So the volume is V equals length times width times the height. So that's going to be 18 times 18 times our 72. Or not 72, 36 I mean, sorry about that. Because that's our length there, right? And 18 times 18 times that 36, that gives you 11,664. And what are our units here? Well, in this case, it's in inches. Now, volumes are cubic units. So this would be cubic inches. And it seems like it's a lot, but it's really not that much when you think about it, because it's just this package, we just multiply them all together. And that's going to be your volume there. Volumes are always in cubic inches or cubic units. Now let's talk quickly about some angles. And we've talked about these before, but we're going to review our angles. And when we talk about angles, there are 3 different scenarios. If they form a straight line like this, if your diagram looks like this, then it's going to sum to 180 degrees. Okay, that's one of them. So if it looks anything like that with a straight line, it sums to 180. If it looks anything like this, like a right angle, and we talked about this a little bit last time, if it's any sort of a right angle, then it sums to 90 degrees. So this one sums to 180. This one sums to 90. If they form an X like this, if it forms an X, the left equals the right, and the top equals the bottom angle. Okay, so those equal each other. So if it makes an X, the top equals the bottom, left equals the right. If it looks like a straight line, they add to 180. If they make a right angle, okay, this is called a right angle here, they add to 90 degrees. So depending upon which one we have is what we'll be working with. So let's do 2 of these, and then we'll take a short break. Now, when we work these out, we have to make sure that we get the actual answers. X is not going to be the answer. You're going to have to plug it back in and get the angles. So let's do 2 of these. Question 68. We'll work with this one first. And these, I think, are about the easiest ones to solve, as long as you remember to plug the numbers back in. So 68 looks like this: 5x plus 5 and 3x plus 5. Now, first off, what do we know about this one? Okay, sums to 90. So that means when we put these together, and you can label them as 1 and 2 if you want, 1 plus 2 equals that 90 degrees, right? So it's angle 1, angle 2. What was angle 1? 5x plus 5. Angle 2 is the other one, and that's 3x plus 5, and that equals now 90. Let me move it up so we can see. Sorry about that. So if you want to, you can just go straight to the equation. If you want to label them 1 and 2, you can do that as well. If it's less confusing, label them 1 and 2, build your equation, plug your values in. Now, we should know what to do. We can begin solving. So, how many x's do we have on the left? Looks like 8x. And number-wise, we have a 5 and another 5, makes it 10. That equals 90. And we're going to move that 10 over to get rid of that. So 8x now equals 80. And what's my next step and last step going to be? Divide by my 8, and x now equals what? 10. Very, very important. This is not the answer. It's only part of it. Okay, how do I find the actual answer? Well, let's go back and fill it in. What does our figure look like? Our figure looks like this. We're going to fill it back in. 5x plus 5 and 3x plus 5. So x is not the answer. We have to plug it back in. So plug in that 10. Plug that in for the x. So that's 5 times 10, that's 50. Plus 5 more makes it 55 degrees. That's an answer. Okay, so that's one of them. What about the other one? Okay, that's going to be 3 times 10 plus 5. That gives you 35 degrees. These are the answers. Those are the answers. Now, very simple question. I like to put a question like this on the exam. Where do students make a mistake? They stop here. Okay, this is not the actual answer. This is only part of it. It's only the value of x. We don't care about x. We want to know those angles. So you plug them back in, you get your two angles, and those are the answers. If I gave you this question on an exam and you stopped here at 10, you'd only get half credit. You have to plug it back in to get the actual values that I want. One more, and then we'll take a short break. Question, how about 72? Okay, so what do we know about this one? Does this form some kind of an X? Yeah, okay. So we know then what? We know these are going to be the same, don't we? Okay, top equals bottom, left equals the right. Easy enough. So what does my equation look like now? 11x minus 37. That equals 7x plus 27, right? Simple enough there. Move the 7x over with subtraction again. And 11 minus 7, that leaves you then with a 4x minus 37 equals your 27. And we're going to add that 37 over. And now we've got 4x equaling. We've got 27 and 37, so that should make it a 64. We will divide by our 4 to get rid of that. And now we've got our value of x. So our value of x is now 16. Is that our answer? No. What do we have to do? Plug it back in. Again, not the answer. Plug it back in. So 11 times 16 minus 37. 11 times 16 is 176 minus 37. Well, that gives you now 139 degrees. So there's one of them. Now these are equal, so what should the other angle be? The other angle should be the same thing. Let's check and make sure. 7 times your 16 plus 27. When I put those together, that also gives me 139 degrees. And we know we did it correctly because these should be what? These should be equal. And they are. So let's take a short break. We're going to come back and we're going to learn about what are called literal equations. So let's meet back here in about another 10 minutes. So let's meet back here at, how about 10:05 again?